Hello everyone. Today let's solve the problem travel card. Right. So this was asked on 8VC Venture Cup 2017 final round. Right. So now you can just go through the question. It's easier to understand. Let me summarize the question so that it will be easy for us to solve the problem. Right. So what the question states here. So we are, or sorry, each trip takes 1 minute and happens at a time t of I. Right. So when I say, just give me a second, 1 second here, each trip takes 1 minute, right? So they have strictly mentioned here each trip takes 1 minute and happens at the time t of I, and happens at the time t of I, right? So this is fine. Strictly increasing they have mentioned, right? So this is also fine. Just keep this in mind, right? So what about the tickets? So here let's speak about the tickets now. Tickets, single ride equals 20. Single ride, so I'll just write here SR, nothing but the single ride, right? So single ride is 20 and 90 minutes ride, I'll just give here 90 minutes, right? 90 minutes, nothing but 1.5 hours ride, right? 90 minutes ride is 50, right? So this is fine. And one more thing, one day, one day ride or 1440 minutes, this one day, or I'll just write here one day or 1440 minutes. So I'll just write here 1440, right? So this is fine. Single ride takes 20 and 90 minutes ride takes 50, and one day or 1440 minutes ride takes this one 120, right? So this is the ticket price basically, right? So after each trip, system reoptimizes minimal total cost for all the trips so far and changes the difference from the previous minimal. What does the system do? See, after each trip, system reoptimizes minimal total cost, right, for all the trips so far and changes the difference from the previous minimal. This is fine, easy. So we must print the incremental charge after each trip. What we need to print here? We need to print the incremental charge after each trip, right? So what is the goal means what we need to compute basically. We need to compute these increments efficiently using DP and binary search, right? So we need to compute these increments efficiently, right? In the sense, uh, see, tickets price we know, and each trip takes 1 minute and happens at T of I. That also we know. After each trip, system reoptimizes minimal total cost for all the trips so far and changes the difference from the previous minimal, right? So this is important, right? So we must print that incremental charge after each trip, right? So we need to compute these increments. So for computing these increments, we will be making use of the DP and binary search. Just remember this one. We'll be going with the approach DP and binary search. Right. So this is very important part, man. Right. So let me delete this one. I hope the question part is completely clear, man. Easy, right? So here we have been given this one. Three inputs basically. Three indicates that we have been given three inputs, right? So this one second. Yeah. This one T we have been given 10, 20 as well as the 30, right? So t, see, t is nothing but the time t of I, right? So we consider t of I, this one, each trip takes 1 minute, nothing but the time, and happens at the time t of I they have mentioned. So t we have been given here 10, 20 and 30, right? So we need to print the incremental charge after each trip, right? So we have to compute these increments efficiently, right? So that's what they have given accordingly with the constraints. So I thought of going with the DP and the binary search. So this will be, so we can basically compute or calculate the increments efficiently, right, by making use of the DP and the binary search accordingly with the constraints. As we have a bit of tight constraints, we can just go with the this one DP as well as the binary search for this particular problem, right? So this is fine. Now we are done with the question part, right? So the answer that we need to get here is 20, 20, 10. Same goes with this one as well, right? So the output that we need to get here is this one. This is fine. Now let's do one thing. As we are familiar with the question now, let's discuss the approach followed by the complexities and then let's write the code. As usual, let's discuss the approach first. See, I have considered the same first example that they have given in the question. We have three inputs, 10, 20 and 30, nothing but this is t, and the output that we need to get here is 20, 20 and 10, right? So let's move on with the step-by-step explanation here. T we have been given 10, 20, 30, this one input part, right? So 10, 20, 30, right? So this is fine. So what we will do, as I've said, we'll be going with a dynamic programming approach, right? So we'll be going with a dynamic programming plus binary search approach, right? I'll just write it here, binary search. This is fine. We'll be going with the dynamic programming as well as the binary search approach. So here, first what we'll do, we'll be going with the DP of I. So as we are dealing with the DP, we'll be going with the DP of I. So DP of I equals minimum total cost to cover first I trips. So this will be going with the minimal total cost to cover first I trips. Means we'll be going with the math.mon. You would have already guessed this one, right? Transition for the trip I should be one index. Just remember this one. This is one index, right? So this is important part, right? So DP of I is minimal total cost to cover first I trips, right? Minimal total cost to cover first I trips, right? So DP of I will be going with this formula. We have been given in the question that single ride for the tickets charges, right? So for the single ride it is 20, for the 90 minutes ride it is 50, and for the one day ride we have been, or 1440 minutes, 1440 minutes is 150 charges, 120, sorry. So we will be going with the formula here, min of dp of I minus 1 plus 20, dp of j90 plus 50, and dp of jd plus 120, right? So where j90 is nothing but the lower bound, this one, you can just see this one, the lower bound of this one, jd, I'm speaking of the last one here, this part, right? So this is j90, jd, this one I'm speaking of, right? These j are counts of trips before the first covered by that pass, right? So these j are counts of trips before the first covered by that pass, right? So this you'll get to know once we write the code. Basically we just have to remember this one, this part, right? So for this part we need to know that nothing but we are calculating, or we are going with dp of I equals minimum total cost to cover first I trips as per the criteria or the question, right? So transition for the trip I, this has to be one index, they have strictly mentioned, right? So this is fine. Now next let's see the iteration part. So we have the three numbers. Basically we'll be going with till I equals 3, right? So we have 10, 20 and 30, or 20, just one second. Yeah, 10, 20, 30. Output we need to get 20, 20, 10, right? 10, 20 and 30. So when I equals 1, t equals 10, right? So we have 10, one second, just one second. We have 10, 20 and 30. T we have 10, t we have 20, t we have 30, right? So one second, here we have been given t equals 10, right? So this is fine, first input. So we'll go with a formula. So this formula, man, where I showed here, min of dp of I minus 1 plus 20, dp of j90 plus 50, for this is for the 90-minute ride, right? So this is for one day. J day is nothing but the one day ride, 1440 minutes, right? So this one 1440 minutes, right? So this will be charge will be 120. For the 90 minutes we have 50, and for the this one, what do we call, for the single ride it is 20, right? So for when t is 20, so we'll be going with the formula 0 plus 20 initially, 0 plus 50, and 0 plus 120, right? So when t is 10, this is single ride, right? So dp of 1 is, dp1 is nothing but the 20, right? So dp of 1 is 20. So here change is 20, right? So sorry, this is not change, man, this is charge. Basically charge is 20, sorry, right? So this is fine. Now I equals 2 we have, means the second iteration, the second one, this one will be t equals 20. We have 10, 20 and 30, right? So we have 20 for the second one. So minimum same, last charge we have got 20, right? So this one here will be going with dp of I minus 1 plus 20, right? So last one I minus 1 we have charged 20, so we will be going with 20 plus 20, that leads to 40, right? So this remains same, 0 plus 50, 0 plus 120, right? So dp of I minus 1, so this is nothing but d9 j90, right? So this is djd, right? So this is fine. uh, this remains same, and this one is dp of I minus 1 plus 20, right? For the single ride, I minus 1 charge we have already found out by the last step, that is nothing but 20, right? So this one will be 20 plus 20, that leads to 40. Now dp of 2 is 40, this value, right? So dp of 2 is 40 and charge still remains 20 itself, charge still remains 20, right? So now next, let's move on with the last part or the final part here. When I equals 3, it's t, we have 30, so we have already considered 10 20. Now we will be going with the 30, right? So min will be last dp of I minus 1 plus 20, last dp of 2 or the I minus 1, we have I minus 1 is dp of 3 minus 1, nothing but dp of 2. dp of 2 value we have got 40 here. This one will be 40 of 20, that leads to 60, right? So this remains same, 0 plus 50, 0 plus 120. So dp of 3 this time will be 50, right? So 50, because the charge is 10, right? So 60 minus 50, this charge will be 10 basically, right? So dp of 3 will be 50, and this one, what do we call, um, dp of 3 will be 50 and charge equals 10. Yeah, this is fine. Now the output that we got is nothing but we have to return dp of 1, dp of 2 and dp of 3, right? In the first, second and third line. So dp of 1 we got here is 20, dp of 2 we have got 20, charge 20, and dp of 3 charge we got this one, uh, what do we call, 10 basically, right? So min of 40 plus 20 we are going with 60, this one 0 plus 50 and 0 plus 120, this one remains same, dp of 3 becomes 50, right? 50, 60 minus 10 basically, right? So this will be, charge will be 10 basically, right? So this is fine, I guess. Now dp of 1 we got 20, dp of 2 we got 40, and dp of 3 we got is 50, right? So this one, sorry, just give me a second here. 20 charge, this one will be 20 because 40 my this one, mm, yeah, 20 we have added this one from the previous one, 20 from the previous one, we are going with this one. This time we have to get 40 plus 20 itself, right? 60, this has to be, so this is fine. T equals 30 we have, right? So yeah, we have to get the charge done, so this is fine. Now we have 20, 20 and 10 for the charge. Basically this is not the dp of 1 2 3, this is charge actually. So this is charge, this is charge, again charge, right? So this one 20 20 10. So dp of 1 value is this one, what do we call, dp of 1 is 20, dp of 2 is 40, dp of 3 is this one 50 basically. If we want to tell, in the case of dp of 1 it is 20, dp of 2 40, dp of 3 it is 50. Charge is this one, charge will be 20 20 and 10. Single rate charge is 20, right? For the 50 it will be 10 basically. uh, we are going with 90, this one, what do we call, uh, single ride as well as the 90-minute ride, 1 day ride, right? So this one will be 20, charge will be 20 for the last one. So 10 for the last one, sorry. So this will be 20 20 10. So the output that we got here is 20 20 10, which is equivalent to the output that they have given for the first example within the question. Simple, right? So the output that we got here is 20 20 10, which is equivalent to the output that they have mentioned for the input one within the example or within the question basically, right? So now as we are completely familiar with the question, let's do one thing, let's discuss the complexities part. So what is time complexity here? The time complexity is big of n log n. So why it is big of n log n here? So each of the n steps does two binary searches here, logarithmic n, right? So this will be overall time complexity will lead to big of n. Also we are going with big of one work, right? So overall time complexity would quite obviously lead to big of n log n. So what will be the space complexity? This you will understand clearly when we write the code accordingly with the approach, right? So space complexity would be, we'll be making use of the array and dp, right? Arrays A and DP. These two arrays will be making use of arrays A and DP to dominate the memory. No extra heavy structures will be making use of, right? So in this case, overall space complexity would lead to big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and big of n respectively, right? So now as we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. Let's start writing the code. I'll just come to the compiler part here. First, let's do one thing. Let's import the input output classes. I'll just go with import java dot io dot star. So this is fine. Next, let me go with the class here. Public class travel car. So this is fine. Now, basically, mm, so we have to return the first index in a of 0 to r, right? This is fine. Uh, as per the approach, we have to go with the this one binary search as well as the dynamic programming. Let's do one thing. I'll just go with the helper method here. Private static here int. So this one will be lower bound. Let me pass here int parameter a, r and b we need. So this one will be fine. Int r int v. So this is fine. So within the helper method, first step is we have to search the space, nothing from 0 to r. So default answer initially it will be r. As we are searching the space from 0 to r, initially we'll consider the default answer as r. We are going with a lower bound, right? So this will be int l equals 0, answer equals r. So this is fine. Now, uh, let's go with a standard binary search, right? So I'll just go with L less than or equal to R here. If you know the binary search, let's calculate the mid. Now this will be L plus R by 2, or I can just write it on this way, L plus R, right shift 1, right? So this is fine. Now, if A of M, if you don't want to write it fancily, this one you can just go with a left plus right by 2, right? So this is fine. Now, A of M, this one greater than or equal to V. So this is fine. This one, let me assign answer to M, and right will be nothing but mid plus 1. Mid we have considered M. So sorry, mid minus 1. Mid we have considered M. This will be M minus 1. Right. So let me write the else quickly. Else what we will do, left is nothing but the mid plus 1, right? So else we have to move right. So basically here what we are doing, if condition whatever I have written, if we have found the candidate greater than or equal to V, we have to move left, right, to find the first. Else we have to move right. So we have already moved left here by giving r equals m minus 1, means we are decrementing m minus 1 means mid minus 1. We are going from right to left. Now else we have to move right, means here I'll just give or else I'll do one thing. Let me do one thing here. Else I'll just write it here itself. Left equals, we have to move right, right, from left to right, basically mid plus 1. So this is fine. Now let's return the answer, means earliest index with a of index has to be greater than or equal to v within 0 to r, as we have discussed. So we have considered the answer variable initially that was assigned with r, right? So this will be, we just have to return answer basically. Now this is fine. Now we are done with the helper method lower bound. Let's write the main method. Now let's come to the main method. Let me give main here. So let me go with throws input output exception. So or we don't need input output, just exception I think. Let's see. So this one, let's go with the fast input and the output first. So I'll just go with, let's make use of the buffered reader, new buffered reader. So this one, new input stream reader. uh, this one will be system dot in. This is fine. Next one will be print writer. So this one will be pw new print writer system dot out. So this is fine. Now let's do one thing. We have to consider the number of trips first, right? So we have to read number of trips first. So I'll just go with n equals accordingly with the input output man. So this is in the type of this is of the type integer. So I'll just go with integer dot parseInt here buffered reader dot read line. So this is fine. The next part here would be we have to go with the trip times, right? So nothing but the a array a had mentioned this one while considering the input output, right? So this one I'll just go with a equals new int of n. This is fine. The next part is let's go with the iteration part. We have to read the times, nothing but here I'll just go with for loop and I equals 0, I less than n. So this will be I plus plus. This is fine. Let's go with iterated value of the a. This one will be integer dot again parseInt. This one will be buffered reader dot read line, right? So read line. This is fine. Now this is nothing but we have read the times as well. Now we read number of trips. We went with a this one trip times as well along with the read times. So this is fine. We are done with that part. Now let's go with a DP. Right. So we know that iterated value of the DP. So this is where we started the approach. Right. So discussing the approach. Iterated value of the DP is nothing but the minimum cost to cover first I trips. Right. So I can just write it in well. Let's initialize the DP first. So this one will be DP equals new long of n plus 1. Next part is we have to initialize with large sentinel, right? So I'll just go with arrays dot fill. Let's fill with tp long as per the constraint, right? So we have to consider the value. I'll just give here long basically. Where did this go, man? 7e9. So this is fine. Let me give you one more parenthesis. Yep. Now, initially, the base case, let's go with the zero cost for the zero trips initially. So this one will be dp of 0. Let me assign with a value 0. Right. So this is fine. Now, let's go with the iteration part. Right. So basically, we have three options here. As per the approach that we discussed, we have three options. One is we have to buy the single ride for the ith trip, nothing but we have to go with the 20 single ride. Option 2 is we have to buy a 90-minute pass to cover all the trips with time greater than or equal to a minus 1 minus 89 up to this one. What do we call? Mm, so this one has to be, I forgot this one. Just give me a second here. 1 second. Mm, So this one we have to buy a 90-minute pass, right? So to cover all the trips. So this is fine. Option 3 is we have to buy 1 day pass to cover all the trips, right? So so this is from a of I minus 1 minus 1439 up to a of I minus 1. The last one was from a of I minus 1 minus 89 up to a of I minus 1 because we are going with a 90-minute trip. So this is one index if you remember, right? So that one. So we have to consider 89 minus 89 and this one 1440 for the 1 day minutes for 1 day 1440 we have to go with the as it is one index minus 1439 we have to go up to a of I minus 1 for both option 2 and option 3. For the option 1 we have to buy single ride for the ith trip. First let's go with the option 1 here. So this one dp of I equals math.min. So this one will be dp of I comma dp of I minus 1. This one will be plus 20. This is fine. The second one will be dp of I equals so this one will be math dot min dp of I. This is fine. dp of this one will be making use of the lower bounds. Lower bound we have already written an helper function lower bound, right? So this one will be lower bound. Parameters is a I minus 1. So this one will be a of I minus 1. This is also fine. Simple. Uh, this one minus 89 as I have said. So this is one index. So we'll not be going with minus 90. Instead, we'll be going with minus 89. So this one has to be plus 50. Right. So this is fine. So we are done with the option 2. Let's go with one more option. Nothing but here dp of I equals math.mun. This is kind of formula. This is not something to mug up. This is based on this thing, the question, right? Or the criteria. 20, this one time, based on the time that they have given, right? So ticket price based on the time. So t equals this one. What do we call? Initially single ride and 90-minute ride, as well as the this one day ride, or the this one 1440 minutes, right? So this is fine. Next, we will go with math.mun of same thing, similar to the second one, dp of I, comma, dp of this one will be lower bound again. So we will pass a I minus 1, same thing. This remains same. A of again I minus 1. This also remains same. Um, Instead of this one, what do we call, minus 89, this will be one day ride, right? So we have to go with 1440, sorry, 1439, one index, right? 1439. Finally, instead of plus 50, it would be plus 120 here, plus 120 here. This is fine. I hope this is fine. We have already discussed this one in the approach. I have stressed this one multiple times as well, right? So this is fine, I guess. So finally, after each step I, we have to charge the incremental difference. Nothing but here, when I say incremental difference, it will be dp of I minus dp of I minus 1, right? So let's go with the iteration part here. This one will be int I equals 1, I less than or equal to n, I plus plus. So this will be print writer dot println. So I'll just type this one entirely. So this is fine. This one will be, when I say incremental difference, it has to be dp of I minus dp of I minus 1. This is fine. So we are done with this part. We are done with the coding part. All we are left with is we have to ensure the output is written, right? So I'll just go with a print writer dot flush, or this one. What do we call? Flush, or we can just go with the close as well. Close or the flush. So I'll just go with the flush man here. Let's ensure output is written. So I'll just go with pw.flush, nothing but print writer.flush, right? So somewhere I have missed the this one. What do you call? Mm, Brackets, actually. Bracket misplaced. I have done something wrong. I don't know where I have done wrong. Just give me a second here. Else I have written here. This one is fine. Written answer. This is also fine. Oh, yep, this is fine. This part is fine. So here we have for loop. So did I close dp of this one considered? Huh? Didn't I write the for loop here? dp of 0, I have considered 0. This is, oh, I have not written the for loop at all here. So this one, dp of I have considered directly. I haven't written the for loop at all. Sorry. So this one has to be I equals 1. Oh, we have to consider I less than or equal to n, right? So this will be I plus plus. So this is the reason. This is fine, man. Let me give one more bracket here. This is fine. Now, we are done with the coding part, right? So before checking the code with different this one inputs, let me copy paste the signature starter template. Just give me a second here. So let me come here. Let me paste this one. This is fine. Yeah. Now let's check the code with different inputs. I'll just copy this one. We have to get the output 20, 20, and 10, right? So this is what we discussed for the approach as well. We're taking this example. We have error here. Oh, mid I have given, m we have considered, right? So m I have to give. Where is this line number 29? Yeah, this has to be m plus 1. Sorry. Now if I run this one, oh, we are left with one error. Error cannot find symbol. Arrays I have given correct, right? Arrays dot fill. Line number 43. So this one we can just go with the arrays dot fill, right? What is wrong here? I don't understand. So long I have considered DP we have initialized with a long type long. This is fine. New long of n plus 1. This is fine for the safer side. I have considered n plus 1. Nothing but DP of I is minimum cost to cover first I trips. This is fine. Arrays dot fill. What is wrong here? I don't understand. Cannot find symbol. Arrays dot fill DP a long of 7 to the power of 9. This is fine, man. We are initializing with a large sentinel basically. Arrays dot fill DP of 0 equals 0 base 0 cost for 0 trips. This is also fine. What's wrong here? Just give me a second here. So yeah, the mistake is C. I have made use of the arrays dot fill here. This is not the wrong thing. So I have just imported the input output package. So we are making use of the utilities from the utility package, right? So I just have to add this one, I guess. I guess so. This one has to be java dot util dot star. So yeah, it's better to add these two, man. Even though if we are not using it, it's better to add these two. So this is fine. Now if I run this one, yeah, now we are getting the correct output 20, 20, and 10. So this is coming from the utility package. So I had to add the util. So this is fine. Now we are getting the output 20, 20, 10, right? So let me copy this one. The output that we need to get here is this one 20, 20, 10, 0, 20, 0, 0, 20 twice and 10 finally. So this is fine. Yeah, 20, 20, 10, 0, 20, 0, 0, 20, 20, 10. So this we are getting the desired output, right? So let me copy the entire code. So let me hit the submit button here. Let's come to the submission part. So this is problem B, travel card, right? So this is rated 1600. So this is fine. Mm, yeah, this is rated 1600 binary search and DP. So this is fine. Let me paste this one and let me hit the submit button. I hope this works for all the test cases. Let's see. Let's wait for some time. So here we have went with pure this one dynamic programming as well as the binary search. Binary search just for the case of just for the sake of this one lower bound. So this is fine just for the sake of optimization actually. Binary search. Let's wait for some time. Yeah, you can clearly see here the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases, man. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.